Hi folks, this is Shefik. Today we are going to mention how to find false negative classifications in facial recognition experiments with Neo4j graph database. But before we begin, please like the video. Do not forget to subscribe to the channel and please click the bell icon to stay up to date with the latest videos. Recently we have mentioned how to find false positive classifications. But today we are going to mention false negatives. What are the differences between false negative and false positive classifications? Let's discuss this first. For example, please focus on the illustration on the left side. Image 59 is directly connected to image 62, but image 59 is not directly connected to image 16. Even though they are both Jack Dorsey, we don't have a direct relationship, so DeepFace verifies this pair as different persons, but actually they are same person. On the other hand, let's focus on the illustration on the right side. Here Matt Damon notes are connected to Leonardo DiCaprio's notes. Even though they are different persons, DeepFace verifies those pairs, image 30 to image 35 and image 29 to image 35. DeepFace verifies those pairs as same person, but its actual label is different person. So this is a false positive classification. We are going to use the same code in the false positive experiment to move our facial image database to Neo4j. That's why I'm skipping the logic behind this code. You can find the details in the other video and in the other tutorial. So I'm going to run this code as is. Thereafter, I'm going to have nodes in my graph database. As you can see, there are 61 nodes per facial image. This query limits our nodes with 25 nodes. I can run this query and it's going to return 61 nodes. And when you click a node, you are going to see its name and also its embedding. Now I'm going to create edges between nodes if the distance or similarity between its embeddings is less than a threshold value. Those threshold values are pre-tuned in the DeepFace side. So in this experiment I used FaceNet model and I'm going to create edges based on the Euclidean distance metric. So its pre-tuned threshold is 10. To create edges between nodes, let's retrieve all node pairs first, match, and get all face nodes and the n variable. Thereafter, get all face nodes again in the n variable. So there are 61 nodes. I'm going to check. Name variables are different. That's why I just added this condition. Node n's name should be different than the node m's name. That's why I'm going to have 61 times 60 different candidates for x. Now I'm going to transfer n and m node pair into the next subquery with command with transfer n directly, not m directly, and also let's calculate the distance between its embedding properties. Graph data science dot similarity dot Euclidean distance, and here I'm going to pass the embedding properties n dot embedding and as a second argument m dot embedding, and I'm going to name this value as distance. Here I'm going to check the distance value is less than the pre-tuned threshold value, which was 10. If this condition is satisfied, I'm going to create edge between node N and node M. Here I'm going to name the name of the edge as distance. Besides, I'm going to set the distance property of the distance edge to the distance value I'll calculated here. This query creates 127 relationships. So when I run this query again, I'm going to see the edge between nodes, and it obviously shows clusters for identities. Please focus on the cluster on the left side in the graph. Let's focus on this. This actually the cluster of Jack Dorsey I just mentioned in this tutorial. Now how can I find the relationship between image 59 and, for example, image 16? Here I'm going to firstly get the face node and check its name is image 59. Thereafter find its connected nodes, and let's say it should be face again, and I can assign this query to p variable and return p as is. As you can see, this directly returns the relationship for image 59 and image 62. But I actually want to access the image 61 via image 62. If I store those relationships in a relational database, I can get this indirect relationship with nested SQL queries. But it's much easier in the Neo4j and Cypher. Let me show you. Here in the edge term, I'm going to name it to R, which is the short of relationship, star 1, 2, 3. This is going to return nodes with relation in depth 1 to 2. And in that way I can retrieve this indirect relationships. I can actually return the names directly, not N name and not M name. And as you can see, even though image 59 and image 61 are not connected directly, I can get this indirect relationship with this query. So in that way I can get the information of false negatives. In other words, image 61 and image 59, they are both Jack Dorsey's images, but they are not directly connected in the DeepFace verification function. But I can get this information via Neo4j graph database. Thank you all for watching and see you next time.